Okay, so let's start your video. I'm not gonna do every question because I don't think it's necessary, but I'll do a few ones that I think you um, might something. All right, so let's start with well the ones that I can do right away. That's 9, right? It's two positives. Here it's a positive and a negative, and there's more of a negative, so I know my answer is going to be negative. So this is going to be negative 2.5. Here, I know my answer is going to be positive because there's the absolute value here is bigger, right? If we take the sign of the bigger of the number with the bigger absolute value, so this 3/9 and 2/9. So this is just going to be 1/9 positive. Both my numbers, both of my rational numbers are here are negative. So a negative plus a negative is just going to be a negative, right? So let's see how many negatives I'm going to end up with. So 4, carrying on, negative 8.4. Again, here both are negative, so let me, you know what? I like doing it this way. So, and I separate my fractions from my whole numbers. So 1/4 plus 1/4, right? So let me just put negative. And 1/4 plus 1/4 is just 2/4. 2 plus 3 is 5, and 5 and 2/4. So if you like to uh, simplify, you can write 5.5, so negative 5.5. Again, these two are negatives. I guess I am doing all the problems. Jeez. These two are negatives. It's okay. So again, my answer is going to be negative. 2.5 and 0.6. That's going to give me 3.1. Negative. Here, and I guess I can erase as I go. I have negative 3/4 plus 1/5. So you have to determine which number has the bigger absolute value, and 3/4 is definitely bigger than 1/5, right? You have choices here. You can work it as a fraction, or you can change this to a decimal. I would change it to a decimal because they're nice fractions that turn to very easy decimals. But I'll do it both ways. So I get a negative. I know my answer is negative. I think you should start with that if you can recognize if your answer is going to be negative or positive, and just start with that, and then you know what you can do. So 3/4 plus 1/5, and if I change that to a decimal, I get negative 0.75 plus 0.2. And I think with a decimal, it's more clear that you can actually tell which one is the one with the bigger absolute value. In this case, is negative 0.75. So 0.75, and I'm not adding these two, right? I'm actually subtracting. So let me add a placeholder, 5, 5, and then I'm going to get 0.55. 10, we're adding all these things. 3 plus 7.5. Oh, and I forgot. Let me do that as a fraction. If I take that as a fraction, I'm going to get negative something over 20 plus something over 20. So the 4, it's a times 5, so I multiply the top times 5, I get negative 15. It's 5 times 4 and 1 times 4 at the top. So again, you can clearly tell that this number is the bigger absolute value. And you're going to get a negative, right? Negative, and there's more negatives over here. 15 minus 4, final answer, negative 11 over 20. Now, just a quick FYI here, that's the same thing as me writing it like this, or as me writing it like this. All three of them will get you a negative answer. Okay, this is a negative and a positive, will give me a negative result. This is a positive and a negative, still going to give me a negative. And this, I'm going to do 11 over 20 first, and then add the negative sign. So all three of them will give me a negative answer. 3 plus negative 7.5. So again, I would suggest you do these like this. Find the answer of those two. So it's a positive and a negative, so I know it's going to be a negative answer, right? So if I write it like this, let me write it over here. You can clearly tell there's more negatives over here. So my answer is going to be negative. And 3 plus negative 7.5, well, we subtract those. And if you subtract 7.5 minus 3, you get 4.5. So that gives me negative 4.5, which I'm going to now add to 1.2. And negative 4.5 plus 1.2. Let's talk about our answer first. Our answer is going to be negative or positive. Well, there's more negatives than positives, so it's negative. So if the signs are different, I got to find the difference between them, right? So it's 4.5 minus 1.2, and I'm going to get 3.3. Final answer, negative 3.3. Negative. Okay. So it's the same story which with most of these questions. Let me do these two, and I'm not going to do all of them. Let me do these two. So it's negative 1.32 plus 5.02, negative 1.32 plus 5.02. I know here the absolute value is bigger, right? This is a larger number, so there's more positive, so definitely going to be a positive answer. And now I have to subtract these two, right? So it's 5.02 minus 1.32, right? Because they're different signs, so subtract the 0. 4, this becomes a 10. 10 minus 3 is 7. Dot 4 minus 1 is 3. So positive 3.70, right? Which I am now going to add plus negative 1.24, right? So I have positive, positive what? 370 plus negative 1.24, negative. So again, let's talk about the sign first. There's more positive, so my answer is going to be positive. And I need to find the difference between these two. So it's 370 minus 1.24. Remember to line up your decimals. 7 is going to be a 6. 10 minus 4 is 6. 6 minus 2 is 4. And 3 minus 1 is 2. So I get positive 2.46. I'm going to skip. I think you can manage 12 and 13. Let's do 14. So 14, I'm going to take the first two first. Negative 3 minus this. Now let's forget that part. Let me underline. Let me forget that for a second. Let's pretend the problem is like this. Now, first thing I would do, and again, I think you should do it because I think it's easier to see. It's change this because it's a subtraction problem, right? This says negative 3 over 2 minus 7 over 4. So let's change the subtraction to an addition. So that's going to stay. The subtraction, I'm going to put a plus. And the 7 over 4 is going to be negative, right? So now I know it's a negative plus a negative. I know my answer is going to be just a negative number. Find the LCM. Well, the LCM is 4. So the second fraction, there's no changes happening. But the first fraction, I got to change it to an equivalent fraction. So it's times 2 here. Times 2, and I'm going to get negative 6 over 4 plus negative 7 over 4. Well, I know my answer is going to be negative over 4. And 6 plus 7 is just going to be 13. So negative 13 over 4, which you're welcome to change the mixed number. Negative 4 goes into 13 3 times, which is 12. 1 left over, negative 3 and 1/4. And I'm still not done because now I got to do the plus 1/8. So let me find some room here. Negative 3 and 1/4. Actually, my mistake, because I shouldn't even change the mixed number. I should have left it like this because I still have the second part. So negative 3 and negative 13 over 4, and we're going to add plus 1/8 over here. Okay, so now you got to decide which one has the bigger absolute value and which one's the larger number in that case. In this case, if you don't know, okay, let's find a common denominator. The common denominator is 8. This one's already an 8, so no changes. So how did the 4 become 8? Times 2. Times 2. So 13 times 2 is 26. Well, you can clearly tell that this is the bigger one, right? So, so negative plus a positive, because this is the bigger one, I'm going to put a negative and find a difference between 26 and 1, which is 25 and over 8. You may leave it like this or change it to a mixed number, which becomes negative 3 and 1/4. Let's do another one. Eeny, meeny, miny. Let's do this one right here. Let's do this one. So 3 3/5. So what we can do right away, you know what? Why don't we just change everything to an improper fraction? So let's do this one. 5 times 3 is 15 plus 3, so it's got 18 over 5 positive, plus 9 times 1 is 9, it's 13 over 9 negative, by the way. And lastly, 1/5, that stays. Now I can change this so that they have common denominators. So you can do everything at once, actually. Right. So that's going to change to 45, and the last one is going to change to 45 as well. So 5 times what's 45? It's times 9. So if I multiply 18 times 9 to 7, it's going to give me 162. 9 times 5 is 45, and then 13 times 5 is 65. And the last one, how did the 5 become a 45? Times 9, and then times 9 on top. Let's do these two first. 162 positive plus negative 65 over 45. I know there's more positive numbers, a larger one, right? My answer is going to be positive. And let's find the difference between 162. And let's subtract these two. And you're going to get 93, I believe. So let's do some borrowing. That's 0. This becomes a 15, which becomes a 12. 7. 15 minus 6, 97. My mistake. So you get positive 97 over 45 plus 9 over 45. Well, that becomes much simpler. It's addition. They're both positive, so it just becomes a larger positive number. 45 stays at the bottom. On the top, 97 plus 9 is, I don't know, 10 something, 106. Which if you change the mixed number, 45 goes into 96 two times, which is 90. And you're going to have 16 left over 45. Let's do just one more here at the bottom. Negative 1/9 plus 8. Okay, so 8 and 3/8 minus 1 over 15. Let's change so we all get a same denominator here. So the same denominator would be, actually the first thing I want to do is change. So it's 1 over 9. 5 times 8 is 40, so it's going to be 43 over 5 minus 115. So the first thing I did was change this mixed number here to an improper fraction. Now I'm going to find a common denominator. That's a negative. That's a minus. That's not a negative, it's a minus. So the common denominator between 9, 15, and 9, 5, and 15 is 45. The first multiple that shows up in their times tables at the same time. So 9 times 5, so on the top is times 5. It's 5 times 9 to give me 45. So I'm going to multiply the top by 9. It's 27, 36, 38, 387. 15 times what's 45? It's times 3, so the top's times 3. So let's start with these two. My answer is going to be positive because there's more here, right? 387, and let's find the difference between 387 and 5. 387 minus 5 is 382 over 45. And then we're going to do minus 3 over 45, which is obviously very easy. So the bottom stays as 45, and 382 minus 3 is just 379, which you can change to a what do you call? A mixed number, okay, which is going to be what? 45, 90, 180, 270, 360. 360, which is 8 times, right? So, am I right? Yeah, 8, 32. Yeah, so 8 times, you're going to have 19 left over 45. Okay. So I believe you were also asked to do, ooh, there's more. Okay. So what did I just do? I did, which one did I just do? I did this one, right? Okay, so you have a few more over here to do. I don't want to do all of them for you. I do want you to be able to check. Unfortunately, I don't have the answer key for this, but it's okay. So let me pick a couple more. Let me do this one right here. Yes, no. Yeah, let me do this one. So it's negative 112 plus negative 3 3/8 plus 4/3. I'm going to change, so it's almost the same as this one. So you would change, I would change the 3 3/8, okay, to an improper fraction, find the LCM, and just do it step by step. So that problem is literally the same. Let me do, well, they're all the same. Let me do this one, just randomly pick. So let's do these first two. Negative 1.091 plus 12.12, who is a bigger number with a bigger absolute value? Obviously, it's 12.12. So I know my answer is positive, right? It's going to be positive something. And that's negative and that's positive. So we have to actually subtract. So 12.12 minus 1.091. Make sure you line up the decimals. And we're finding the difference in this case. I'll do some borrowing from this. So the 1 becomes a 0. The 12 is going to become 11, and that 10 is going to be 10. 10 minus 1 is 9, 11 minus 2, 11 minus 9 is 2. That's going to be a 0, 2 minus 1 is 1, and you're going to get 11. So this is going to give you 11.029 positive. We're now adding that to a negative. It's going to be a positive plus a negative, right? Negative 0.1. There's more positive, so I definitely, again, this is going to be a positive answer. And because the signs are different, I'm going to find the difference. 11.029 minus 1.1. Placeholder, 0, 0. So there's going to be a little borrowing here. So this is going to be 0. That's going to be 11, which turns to 10. And this is going to be a 10 as well. 9 minus 9, 9 minus 0 is 9. 2 minus 0 is 2. 10 minus 1 is 9. 10 minus 1 is 9 again. Final answer, 9.929. Okay. Bottom. So we wanted to. So a rational number is a number that can be expressed as a ratio of two integers, right? So how do we change this to something that looks like this? A over B, where A is an integer and B is an integer as well. So the first one is pretty simple. You can just look at this last place, this last decimal here, and it's in the hundreds place. So we can just write 32 over 100. If you'd like to simplify, you can. Divide it by 4, that's 8. Divided by 4, this is 25. So 8 over 25. And you can see that this is an integer, and that's an integer. So if I can express as an integer, it's a rational number. So this takes care of 10, which you can do. It takes care of this. Let's look at 714. And again, look at the last digit. It's in the thousands place. So I'm going to write 1000. And on top, I'm going to write that number, 17875. You can simplify, but right now, what we're trying to do is just make sure that we can write it as a ratio of two integers. Therefore, just proving that it's a rational number. So that you can do. This one you can do. This one you can do. This one you can do. This one. Even negatives, they're the same thing, same thing, same thing. So let's focus on the ones with repeating. See if you can change that to a fraction. So I'm going to do one of each. So let's do this one, 9.7. So how do we change that to express that to something that looks like this, right? An integer over an integer. Well, set this so that x equals to 9.7. You know that there's one number repeating, and if there's only one number repeating, we're going to multiply both sides by 10. So if I multiply x by 10, I get 10x. If I multiply this by 10, what's the multiplying by 10, where you're making it bigger by 10, right? So literally you're just moving this decimal 1 over. So that's going to become 97.7. So just imagine for a second that you had this, right? And I had to multiply this by 10, right? So it's going to get bigger by a factor of 10, so it's going to be 97.10. So that moves 1 over. Now we can use these two equations to subtract, right? So let me just rewrite this, so I think it's easier for us to see it. I'm just putting that on top and the other one at the bottom, and then I'm just going to line my decimals. So it's 97.7 is a bar notation, by the way, forgot, and 9.7 bar notation, right? So make sure the decimals are lined up. And what we can do now is subtract. So 10x minus x, so imagine if you have 10 x's and you take 1 away, you're left with 9x. If I subtract this, and then let me just extend this for a second. It's 9.777 forever, never, never. This one's also 777 forever, never, never. And you can see that they line up nicely. So if I were to subtract 7 minus 7 is 0, 0, 0, 0. So all this on the right side of the decimal would go away because it becomes 0. Decimal comes down. I need to do a little borrowing. This becomes an 8. That becomes 17. 17 minus 9 is 8. And this comes down. So I have 88. I'm even going to erase this, so I don't need it. Now, I want to isolate my variable. Remember when we did one-step equations last year? So I'm going to divide this by 9, and I'm going to this by 9. By doing that, what happens to my 9s? They divide each other out, right? 9 divided by 9 is just 1. I don't need to write 1x because it's implied that there's 1x. So they cross each other out, becoming 1, or we can just simply write x. And on this side, we can write that it's 88 over 9. And if you were to divide this, 88 for 9, you would get 9.7, repeating. And just to like confirm this, let's do that. Here's 88. Here's 9. Let's see if that truly gives us this answer. 9 goes to 81 9 times. 88 9 times, which is 81. Subtract, I get a 7. Add a decimal, add a decimal, add a 0. 9 goes into 7 times, right? 9 times 7 is 63. Subtract, I have 70 minus 63, which is 7. And guess what happens? We're going to have a repeating 7 forever and ever. So 9.7 or just 9.7 bar notation, because this would have gone forever and ever. So there you go. We just proved that this works, and so 9.7 is a bar notation. Is the same thing as 88 over 9. I will do. Let's do this one. Okay, 3.34. So we're gonna set that x, right, equals 3.34. And because it's two numbers that are repeating, this time around, I'm going to multiply by 100. So x times 100, it's 100x. And if I multiply by 100 on this side, this decimal is going to move over, right? So just let me write this. It's 343434 repeating, right? So bar notation on top. So just imagine that I just took that out and what do you call it? Expanded a little bit. So by multiplying by 100, this decimal moves 1, 2. That's the new location, so it becomes 334.34. So let me erase this. It doesn't become, so it's going to become 334 point, so it's going to move 1, 2, 0.34, 34, 34, dot, 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 forever and ever. Let me rewrite this. So on top, I get 100x equals 334.34 repeated. I'm going to take this one, write it over here at the bottom. X equals, and our original number was 3.34, right? Bar notation right here. So I'm going to line up my decimals. I'm going to write 3.34 bar notation. And what are we going to do with these? We're going to subtract. So 100x minus x, if you take 100x minus x, you get 99x. Equals, on this side, on the right side of the decimal, you got 34, 34, 34, continue on and on. Same thing at the bottom, 34, 34, going on and on. So all this, if I subtract, it becomes a 0. So I'm not even going to write it. 334 essentially is, so this becomes essentially 334 minus 3. So 4 minus 3 is 1. Bring the 3 down, bring this 3 down. I'm going to divide both sides by 99. These will turn into 1, or just x, 1x, and x equals 331 over 99. So the number 3.34 was the bar notation repeated as a ratio of two integers is 331 over 99. It's pretty neat. Okay, that one is done, that one's done, you can take care of it, and then I'll do this one. Okay, 0.8. Did I do that one already? I wonder if I did it. I don't think so, did I? Well, I'll do it again. So 0.8 bar notation. I'm going to set that to x, so this means 0.88888 forever, and I want us to find out if we can write that as a ratio of two integers in this format. So we have one number repeating, so therefore I'm going to multiply that by 10. So x times 10 is 10x. And on this side, and let me just write that here. So imagine if you had 0.88888 dot 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 forever. I'm going to move multiplying by 10, makes it bigger, so that decimal moves 1 over, and I end up having 8.8888 dot dot forever, or just bar notation like that. If I subtract, let me rewrite it. 10x equals 0.8. Sorry. 8.8 with bar notation over, let me write that one at the bottom, x equals 0.8 bar notation. Let's subtract. 10x minus x is 9x, and 8.88888 forever never minus 0.888 forever never, the forever never 8s will be 0, and 8 minus 0 is just 8. Let's isolate our variable, divide this by 9, divide this by 9. On this side, these two 9s become 1, and x, clean it up, becomes 8 over 9. So 0.8 bar notation is, as a fraction or as a ratio of two integers is 8 over 9. Okay, so the rest you should have no problem finishing them, hopefully. And we're done. Okay, that was not that bad.